All right, so this is the AB 2016 number 3. They give me a piecewise function on the right there from -4 to 12, and that's the graph of f. G is the function defined as the integral expression from 2 to x f of t dt. So for the first part, they want us to know, does G have a relative max or a relative min, or neither at x equals 10, and of course justify your answers, so we should show some kind of work in here. So first things first, I would just think about that integral expression, and if I'm finding relative max, relative mins, I should find critical numbers, and that's where the first derivative equals 0. So let's go ahead and find the first derivative. So we'll find g prime. So we're basically taking the derivative of the antiderivative, so that's the derivative of this antiderivative here, and those essentially cancel each other out. Second fundamental theorem of calculus, that would be f of x. So I want to figure out, where does that equal 0, or where is it undefined, and there's 4 spots where that equals 0. It's at -2, 2, 6, and 10. So that's basically these 4 spots right there. But of course, they just say what happens specifically at 10. So I'm just going to build a table based around 10, and I'm going to do a sign chart table on G prime to see, or to justify my answer and see if I think it's going to be a relative max, relative min. So I build a little table, throw 10 in the middle, and then pick numbers, sample numbers right around it. 9 and 11 is good enough for me. And then if I think about it, all right, well, 9 is a negative value. That's this point right here. 11 is also a negative value. That's this point right here-ish. And so since that sign doesn't change on those two, since the sign doesn't change, it is not a relative max or a relative min. So this one is going to be neither. And for part B, they ask if the graph of G has a point of inflection at x equals 4. So point of inflection, that'd be where the second derivative equals 0 or maybe undefined. And so I'm going to kind of use what I used from part A, that G prime of x equals f of x. And then, of course, the derivative of that would be G double prime would equal f prime. So we can just derive both sides there, essentially. So I'm looking for where the slope there, the slope on f equals 0 or is undefined. That would be a potential inflection point. Now, for it to actually be an inflection point, of course, the sign has to change on that. So the spots where f prime equals 0 or undefined would be, well, kind of a lot of spots. That'd be at 0, 2, 4, 8, and 10. So 0, 2, 4, 8, and 10. Basically, all those sharp turns, all those cusps are undefined slopes. So that's where the slope would be undefined for those. So those are my potential inflection points. Now, once again, they only ask specifically at x equals 4. And so I'm going to just build a sign table again, this time using the second derivative of g, which really is the first derivative of f. So I'm going to throw 4 in the middle, pick some sample numbers right around that, like 3 and 5. And I want to figure out now, what is f prime? What is the slope from 3, or at 3 and then at 5? So the slope would be positive to negative. So if I think about at x equals 3, the slope at this point is positive, and at 5, the slope at that line equals a negative value. We can figure out what it is, but it's just a sign chart, just positive or negative. Since those signs change, it goes from positive to negative, that ends up being an inflection point at x equals 4. All right, so for part C, they ask us to find the absolute minimum value and the absolute maximum on that interval. So max and min values, I need to, absolute max mins happen at 2 spots, either at relative max mins or at the endpoint. So I want to build just a normal table, xy table, or g of x table, and I want to throw -4 and 12 on my endpoints on the table is like my start and my stop, and then any critical numbers are going to go in between there. That's where relative max and relative mins can happen. So I'm going to go ahead and just build a table, x and g of x, -4 to 12. Those are my endpoints, and then I have to find the critical numbers. Now, I already found the critical numbers in the previous part of this, but g prime equals f, where that equals 0 undefined, are my critical numbers, and so there's 4 critical numbers on this one. Now, there's a couple that are not going to actually be relative max, relative mins. Like number 10, we already talked about why that doesn't work, but basically I'm going to scratch out 2 and 10 on this one, because at x equals 2, I go from a positive value to a positive value on f. which means g prime, right? And then also I go from a negative to a negative, and so since those signs don't change, those are not going to be relative max mins, so then they can't be absolute max or mins. So I'm going to leave those two off the table, if you will. So let's go ahead and take our other two values, negative 2 and 6. We'll throw those into the table, and I just need to figure out what are those function values. So I'm going to plug in all of those values in for x. So this does take a little bit of work, a little bit of geometry to figure out what these are going to be. But I'm going to plug in negative 4 first. So that'd be the integral from 2 to negative 4. The bounds are backwards, so I'm going to go ahead and switch the bounds and make it a negative, and then I have to figure out how that turns out to be negative 4. So if I go from negative 4 to 2, so that essentially is this area and this area and this area. Well, the first two cancel each other out. It's above and below the same amount. And then I have this area right here, so that, just find the area of that triangle. That would be 2 times 4, which is 8, and half that's 4. So then, and then it's negative because of that sign that's in the front, because we essentially changed the order. You can go backwards, and anything above is negative and below is positive, and you'll get the same answer if you do that. So finding the next value, negative 2, I'll just plug in a negative 2. Same thing, 2 to negative 2, I don't like to go backwards, so I switch the order and make it negative. And so that should give me negative 8 for this one. But if I start at negative 2 and go to positive 2, I'm basically finding the area of that triangle right there, which is, looks like 4 times 4 is 16. Half of that is 8. And then since I am going backwards, or I changed the order, it would just be a negative 8 for that one. And to find g of 6, we'll plug a 6 in. I don't need to change the order on this one. 2 to 6 is just moving left to right, and so that should just be the area of 8. So we're starting at 2 and going to 6, so that's basically all of this area chunk right there, and that's 4 by 4, 16. Half of that is the 8 for that one. And then the last one is plugging in a 12. So g of 12, going from 2 to 12. Don't need to change the order on that one. And I get negative 4. I'm basically starting at 2. So if I go to 2, I'm going to go all the way to the end to 12. So 2 is going to give me all this area and all this area. Those wash each other out. And so I'm really just finding the area of this one small triangle, and that is 2 by 4, which is 8. And then half of that would be my negative 4. Oh, and it's negative because it's below that axis. So now that I have my table filled out, I'm just looking at whatever the highest and the lowest y values are. And so the lowest y value there is negative 8, and the highest is 8. And so my absolute min would be at negative 2, negative 8. My absolute max would be at 6 and then 8. And for part D, they say for negative 4 to 12, find the interval where g is less than or equal to 0. So this one's a little tricky to think about, but we're accumulating values of that f, and that's the actual function values for g. So if I'm thinking about this, I'm actually going to bring in that table that I did from before, and it just gives me a little bit of insight of what's going on here. But I just have a table for x and g of x, and I see I've got negative values. I've got negative values to start, and then it goes to positive 8, and then it goes back to a negative value. And so I'm thinking like g is less than 0 at the beginning, and then it's greater than 0, and then it's less than 0. So I kind of have my intervals built into that table just a little bit. So what I would want to do is try to figure out where does this actually equal 0. The integral starts at 2, so at x equals 2 is where we're starting, so everything is based off of that. So if I find values for x, it's going to accumulate the values of f to give me this g value, if you will. So I want to try to figure out when does that actually equal 0. Some spot in between there, it equals 0. Well, for an integral, if I go from 2 to 2, if I don't travel at all, that value would equal 0. And then I'm thinking, all right, well, if I start at 2 and then I'm moving to the right, I'm trying to figure out when will I balance out? When will I hit 0? Well, if I go like this little zone here and this little zone here, I clean out at like 10, or I balance out at 10. So I think that there's a couple spots where this would equal 0 at x equals 2 and x equals 10. And notice that fits right in between there on the x value. So that's kind of nice. It confirms my answer just a little bit. So if I think about that, when I'm doing the integral, from 2 all the way to the right. It's positive as I accumulate. If I think about accumulating all of these, it's positive. And then these I'm subtracting, but it doesn't quite break even or 0 until 10. And then once I hit 10, that's where it starts to go to these negative values. So from 10 to 12, I get this negative value idea. So that hopefully makes sense from 10 to 12. The little tricky one to figure out is, well, the negative from -4 to 2, how does that one show up? Well, if I notice in my table, if I pick any x values like -4, -3, -2, those are all less than 0. The reason is if I'm starting at, let's say I'm starting at 2 right here, and I move backwards. If I start adding this value right here, since I'm moving backwards, and technically it's above the axis, that would be a positive value. But since I'm moving backwards, it actually accumulates negatively. Think about it this way. If you were to start at 0 and go to 2, you would have to change the order on the integral bounds, and so you have to put a negative in the front. And so that's kind of what's happening on this one. Started at 2. I'm basically adding negative values. I'm adding negative values because I'm moving backwards. Now here I'm technically adding positive values because I'm moving backwards and it's below the axis. But the area of this chunk right here never gets bigger than the area of this chunk right here. And so all the way until -4, I will get negative values for g on that function.